you're going to want to have your introduction to minerals and rocks activity, right? So this week we're talking about rocks and minerals. There's a lot of optional activities. I don't anticipate you doing them all, but they're there for you if you need more practice with the rocks and mineral stuff before you take your quiz. I don't think there is a quiz. Did I put up a quiz? I didn't put up any quizzes, so oh well, no quiz for you. So so these will walk you through more of what we're going to do today. So they're worth more points than normal because they're quizzes that walk you through it. So I'll show you the first one. It's not like I mean, it is a graded quiz just because it wants you to choose the right answer. So let me show you what this one looks like, just so you get an idea of how it's set up. So I'm going to talk a lot about this stuff. There's some explainer videos that walk you through it too. I borrowed this from somebody on the Canvas Commons. So this one's about rocks and minerals. So this one's about minerals. So you'll watch a video and then you'll answer questions based on that video. So the videos are short. They're like 4 or 7 minutes, things like that. But because we can't be in person to look at the minerals like we would in class, I came up with this one. I didn't make it myself, but so basically you would just answer the questions based on the videos. And that's why it's worth so many points, is because there's lots of little questions to answer, reflection things like that. So there's even some, like, you're supposed to find some materials around your house, you know, that are about the same size. So I don't know, maybe like a pen and a pencil and I don't know, a ruler, whatever you got around your house. And then you're supposed to order them from softest to hardest. And they talk about, you know, how you can determine the hardness of a surface and things like that. So it's kind of cool. If you have some time and you want to do it, go for it. If not, it doesn't count against you if you don't do it. And when it's all said and done, it's only going to be worth 10 points, but it's set up right now as if it's worth a gazillion, but they're only worth 10 points. So don't go, oh, it's worth 50 points. I can get a 50 out of 50. Yes, you can. But when it gets put back in at the end of the week, it's just going to be worth 10. But I don't know. It was easier than going in and making these worth like a half a point a piece or something. I guess I could do that, but I still have to hand grade it anyways. So, so don't get too excited. I'm just saying. Don't pay attention to the points. It's just the way they're set up. And they're all set up like that because they were all done from the people at Fresno State came up with them. So just that's, in case you want more practice after what we go through today, they're in there. So, all right, so I'm going to go through this intro to rocks and minerals activity with you today. I have some slides that I'll share with you after class also, but right now I'm going to share my screen. So this is our introduction to rocks and minerals, a lab experience. So I'm just going to be going through again the lab. Hopefully I'll get through a good portion of it. So we're going to start by talking about, what is a mineral? So minerals have 5 factors that make them minerals. In the lab, it says there's only 4. The one it's missing is the which one is it missing? Natural? Oh, a solid. So minerals must be solids, is the 5th one. So it can't be a liquid or a gas, otherwise it's not a mineral. It's naturally occurring, meaning that it wasn't made by humans, which kind of makes sense. So like cubic zirconians, which are like human-made diamond-looking things, do not qualify. So It has to be naturally occurring. It needs to be inorganic for the most part. There are a few organic minerals out there, but for the most part, it's not composed of living or once living organisms. It has to have a definite chemical composition. So, for example, halite or sodium chloride or salt, rock salt, has a chemical composition. It's NaCl. There are others out there, other minerals, silicon dioxide, SiO2, and things like that. And then the other thing it has to have is an ordered internal structure. So that's based on how the elements bond with each other. So this inorganic compound right here. Oh, I meant to talk about organic. Organic means it's got carbons. Do I talk about that? I feel like I talk about that. Hold on, I'm trying to do this off of memory when I have notes, which is kind of funny that I'm, spending all this time fumbling around looking for my notes. Okay, so all right, so yeah, that's the chemical equation for chocolate. So it's organic. It's got oxygens and it's got carbons. Carbons make it organic. Anything with carbon is considered organic on our planet. So yeah. All right. So how many different kinds of minerals? There are about 4,000 or so minerals found on the Earth. They each have a unique set of properties. Some minerals are really abundant, like quartz, where others are rather rare, like our state gemstone, which is called bentonite, which is a blue mineral. I have some pictures of it. Now my next slide. This is what it looks like under black light, which is kind of funny. Sometimes it fluoresces blue like this. Other times it'll fluoresce green under ultraviolet light. But this is what it looks like in its rarest form. This thing goes for about $4,000 per carat. It's that rare. It's only found in California, which is kind of cool. It's found in our state rock is called serpentinite. And when that sedimentary rock, metamorphic, no, it's an igneous rock. So serpentinite is an igneous rock that forms inside volcanoes. When that rock is metamorphized, it turns into the rarest gemstone found in the world. So it's got this blue color to it. It's found in hydrothermal rocks. It's extremely rare, but because of it forms in convergent plate boundaries and low temperatures and high pressure. So we're talking not our part, but like San Benito and above. So above San Francisco, all the way up to the Oregon border is where you're going to find it. And it fluoresces, like I said, this bluish white color under UV light. And under clear white light, they'll actually fluoresce green, which is kind of cool. But again, it's very rare to find them. This piece right here is that I found on eBay. I don't own it. I was looking it up, is like $5,000. It's like half a carat or something like that. I was like, dang. It's not even like gem quality. So I don't know why they want so much. Maybe it was $600. I was this close. I was like, oh, do I really? Oh, that's so cool. That would be cool to have in my collection, but I don't have anywhere to display my collection. I still have bugs sitting over here that need to be displayed. If any of you are entomologists or know one, I'm willing to pay to have somebody mount my bugs. Anyways, so there are two different types of minerals, basically. They are either silicate, which means they contain silicon and oxygen, or non-silicate, which means they don't have silicon, but they still have oxygen. And so there's a video that we're going to watch right now. Woohoo! After this commercial.
Hey, if you love working out but chronic pain in your back, knee, hip, or shoulder is holding you back.
Hey there guys, it's your favorite backyard geographer. As we previously learned, minerals can be identified based on their physical properties. But minerals can also be categorized as being silicate or non-silicate. So let's learn about the difference between silicate and non-silicate minerals. To begin, let's identify some differences between silicate and non-silicate minerals. So, silicates are minerals that have silicon as part of their chemistry. Silicates form 90% of the Earth's crust. Lighter colored silicate minerals are called felsic minerals, as they lack iron and magnesium. Darker colored silicate minerals are called mafic minerals, as they do have iron and magnesium. Now with non-silicate minerals, these are minerals that do not have silicon as part of their chemistry. Non-silicate minerals can also be broken down further into 6 smaller groups, such as oxides, sulfides, sulfates, halides, carbonates, and native elements such as copper. So how do silicate minerals form? Silicate minerals form when molten material cools and crystallizes. The pyramid observed in the right consists of silica and oxygen. It's the building block for all silicate minerals. Note how the silicon element is in the middle, and then on the outside are 4 oxygen molecules. That bond is called a silicate tetrahedron, and this is truly the building block for all silicate minerals. Well, how do non-native silicate minerals form? Non-silicate minerals form often in sedimentary, and some, not many, form also in metamorphic rock. Many non-silicate minerals have economic value, as they provide metallic resources such as copper, lead, and iron. So the next question would be, is it a silicate or a non-silicate? So before we begin, I wanted to provide some examples of different specimens.
I love this
What's
guy's
interesting is
map
that silica is
and
not
his Disneyland
available
thing.
in the normal environment. So this is an actual piece of solid silicon that was pulled out by a chemist, by a
He
scientist.
has animals just like I do.
Now, I have 4 samples that I wanted to share with you, and the question is it a silicate or a non-silicate? So the first thing I'm going to show you is this specimen here. If we notice some of its physical properties, it's very, very heavy, it's metallic in luster. This is known as galena. Is it a silicate or a non-silicate? The next sample I have is a really shiny, pretty piece, very glassy.
Quartz.
You see that it has conchoidal fracturing. We do know it's pink, but the main piece here is that this is a piece of rose quartz. Is it a silicate or a non-silicate? The next sample I have, notice its unique geometric design. You can see that it forms and develops in cube shapes. This one, luckily for us,
tastes like salt.
Is salty. This is known as halite. Is it a silicate or a non-silicate? And the last one I'll share with you, again, crystalline shape, purple in color. You can see that they're single terminal pieces, so that they're adhered. This is known as amethyst. Is it a silicate or a non-silicate? Be sure to put your answer below. Hope this was helpful, and we'll talk soon.
All right, so sorry, go away, little YouTube video. Why? What happened to my? Whoa, wait. Shh. Okay, sorry. All right, so one of the things that there are 4 commonly mined conflict minerals. These are minerals that people fight wars over. It's not just diamonds. Diamonds catch the news, but these are 4 minerals that are extracted most commonly in Eastern Congo and pass through a variety of intermediaries before they turn into consumer electronics such as smartphones and tablets and computers. I'm not sure if you know, but there is actually quite a bit of gold in your cell phone. When I was a high school teacher, we did a like a cell phone exchange where students, not an exchange, where students could turn in their old cell phones. And then we sent those to a company and they mined the gold out and then used that money to buy water resources in the Congo, which was kind of cool. It was I was at Baldwin Park High School and they had a I was part of the Earth Academy, and there was a huge humanitarian focus to the schools within a school. And so anyways, these are the 4 top conflict minerals. So yeah, gold's one of them. But there's also wolframite, which is kind of cool. We use this for, you know, dart tips and golf clubs, and it creates tungsten, which is a highly corrosion resistant whatever you call it, bimetal. And so we use them a lot for, like, you know, drill bits and things like that, because it's really strong. So anyways, these are important. So now we're getting into the questions. So that was just the background information, I guess. You're supposed to select, oh, that's what we're supposed to do. Sorry. So question number 1 says, select one of these 4 minerals and talk about how it meets the 4 of the criteria for being a mineral. So if you remember, there are 5 criteria, solid. So don't talk about that one because they're all solids. All right, so let's talk about, do they have an organic structure? No, they're all inorganic. So they are not made by man. They are, they have a chemical composition. So for example, gold nugget is just AU. This guy here is Fe something, and magnesium and nitrogen Mn WO something or other, according to the paper. Let's see, where does it say it? Aha, FeMnWO4. So it's an iron ore or 1 manganese atom bonded with a tungsten atom and 4 oxygen atoms. So they all have a chemical composition, which is all written down here. This one's even more crazy. FeMnTA2O6. So, and then they all have, you can see the physical characteristics of how they form their crystalline structure, because this one here has, we'll get into it next, cleavage. So it breaks along those bonds really easily, whereas this one is more, I mean, it still has a structure to it, but it's not as, you know, squared off as these guys here. But so you can pretty much just write down, yeah, it fits all these things. Okay, let's get to the cool parts. All right, so mineral properties. Okay, so minerals can be identified based on their physical characteristics. And of course, the first one is color. Like, hey, look, this one's pink. Oh, this one's green. This one's blue. And a lot of times it's okay, yeah, it's what we see. It's our go-to characteristic for a mineral, but really it's not the best. In fact, all of these minerals here are all the same. They're just different colors. This is all quartz. So here's amethyst quartz, there's a smoky quartz, there's a rose quartz, there's the like the clear one, which we call glassy. So these are all quartz. So they're not great for, you know, determining what kind of mineral it is. Yeah, it's the first thing that we see. So we start with that. But there are other things that we're going to talk about coming up here that are a little better at helping us narrow down the stuff. So the first one, so it says minerals, blah, 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 color is readily observable. I already said that. The 5 basic properties that we're going to talk about are color, streak, luster, hardness, and cleavage and fracture. And we're going to take them one at a time. So using the specimen provided below, which is fluorite, the following question: what is the general color of the specimen? Which apparently I didn't put the picture of it in my slideshow. I apologize, but it's this little green guy right here, this clear glassy-ish green thing. So hopefully you're looking at that. So what is the general color? I would say it's like whitish, clearish, maybe got a green tint to it, at least in my printing of it. So we'll start with that. What is the general shape? Well, I don't know. What do you say the shape looks like? Let's see. I need a better picture. You pull up my printed version is not the best, apparently. Let's see here. Oh no. Okay, here we go. Oh, yeah. So how would you describe that shape? They're not really squares. They look like pyramided on top, so they're probably pyramided on the bottom. So we call it a diamond shape, which is kind of weird because, you know, anytime I don't know if you've, have a diamond ring or anything, but that naturally occurring, they kind of look like that. So I would call it like a diamond shape. It's not really a square. It's not really a triangle. This is meant to show us that it kind of has that pyramid on the top and the bottom. So I would say it's a diamond shape. The next question is it shiny like glass, reflective like metal, or greasy like a candle? So that's a multiple choice question. So you just write down what you think it is. If it's dropped, do you think it would shatter or break into a geometric design? So that one you're going to have to, what do you think? If I dropped it, do you think it would break in the same kind of, yeah, it might become a hexagon. I have a feeling that if we dropped it, it would just continue to break into the same like set of pieces. I don't know. I haven't had any real experience with it. As of late, I don't have any fluorite in my collection. I have a collection of rocks and minerals. I should have brought them out, but I didn't want to spend time talking about them because I get all geeky about it. For those of you who have me for lecture, you know that yesterday I got all excited because I watched the Black Panther, and I was more excited not about the movie, but about the locations that the movie shows. And so then I went into this like rat hole of Marvel movies and where they're shot. So then I went to Iron Man, the first one, and that's shot in the Alabama hills of California. And I was like, hey, I know where that is. Hey, I know where that is. Oh my gosh, I know where that is. And then I was like, hey, wait, that's Point Doom in Malibu. And oh my gosh, this is so and so. And so I've been like totally geeking out on that. So, I'm like a dog with a toy. I just want to shake the toy. So it's never a good thing to have me try and get through a lot of stuff and then talk about my rock collection or my mineral sample collection. So I just didn't. So anyways, so all right. So we're done with those questions. Cool. So yeah, I would say it's gonna break in the same kind of shape. So yeah, I would say it would break. It's not gonna shatter. It's not like glass. None of these would really shatter like glass because they have that that organized shape to them. It's a property of a mineral. It's this thing. They have an internal structure as the house. So they're not gonna they're gonna break, but they're gonna break in a pretty we call it like a organized manner is what I would say. All right, so again, talking about color, there's a link if you scan the little QR code in your thing, but I'm just going to go to this. So the first one, it says identify 4 different variation of quartz. So here we go. Let's look at what the link says. So here are 4 variations of quartz. There are others, but you can just write these 4 down. So amethyst, rock crystal, rose, and smoky. There are other colors, yellow, brown, green, which I showed you. There's some blue quartz and stuff like that. It says there's the yellow one. Okay, it doesn't. smoky sandstone. Yeah. There's this one, agate, which is a crypto crystalline. The yellow one's called citrine, like citrus. Oh, this one's kind of cool. But so that was the link for that one. So just write down 4 of them. Oh, and the color. So let's see. Amethyst is purple, and rose quartz is a pinky color, and smoky quartz is, I don't know, like a grayish, brownish color. And then rock is, well, that I don't know if you'd call it clear colored. What do you call it? That's why I said citrine. Because that one's yellow. So if I go, this one here is called citrine. This one's called olivine. I don't know what the blue one's called. I don't have any blue, so I have a, oh no, that's not this. That's one of these. Okay. And then it says it wants you to talk about green minerals. So again, there's a link or a QR. These are all green minerals. So you're just going to pick, you know, I think it wants you to pick 4 of them. So let's see here. See, it's called green quartz. I like that. So this is what green quartz looks like. So anapatite. But you can write down any of these, you know, emeralds, diopatase, auricalcite. I used to call this artichokeate, but it's not. It's auricalcite, artichokeate. Calopyrite, pyrite, not pyrite, calophyllite, viridolite, green topaz, olivine. I said that one already. Malachite. And then it wants you to do the same for the blue ones. So these are some blue minerals. So azurite, it's kind of cool. It's one of my favorites. It looks like this. It's like blue and green. It looks like a blue-green, almost like a
light turquoise.
Yeah, almost like a turquoise, but I was thinking of granite. It take it for granite. But it's blue and green. So, but yeah, it has a turquoisey color to it. Turquoise is actually a blue mineral, so that would be another good option to put in there.
Well, it's also
sapphires, diamonds, you know. Topaz. Most people don't think of topaz as being blue, but there is a blue topaz. Most people think topaz is yellow because the birthstone of topaz is usually you have a yellow stone for topaz, but there's blue topaz also. So you're just supposed to pick 4 of these. So I'll leave this up for a second so you can just pick. Okay, so it says explain why, although the most obvious tool for mineral identification is color, not the most accurate or definitive tool. It should be a couple of sentences in length. And so any guesses? I kind of hinted at it. One is this thought, right? But there is another reason. If you look at these here, so I'll look at these blue ones again. And we'll look at the blue topaz, right? So if I found a piece of blue topaz, a lot of times they're embedded with, actually, I'll show you California's. I can never spell it. So, so you can see, so this is the mineral part, but a lot of times it's embedded in other like minerals. And so a lot of times it's, yeah, there's like bentonite in this specimen, but you'll see here's a nice one. It's in white Natrolite rocks matrix. It's $2,000. So you want to get your favorite, geography teacher at Fullerton College, or your least favorite, depending on what your current, just me is the intent. You all want to chip in. Nice California gemstone, preferably in a uncut, ungemified manner, such as this would be just great graduation gift for me. I'm just saying, this one's kind of cool. This one's probably, so yeah. This one's 6 by 3 centimeters. You know how big that is, right? That's like, yeah. Centimeters. At least it's not in millimeters. So anyways, so a lot of times they're have other things, other elements that are embedded with them is another good reason why. So sometimes it's that the mineral can be found in different colors, like quartz, and other reasons why color is not a great way is because a lot of times they coexist with other minerals, and so it's hard to kind of find the forest in the trees, I guess is the way I would put it. Okay, maybe not forest and trees, but you get the point. All right, so the next property we're going to talk about is streak. And streak is basically the color of the mineral in powder form. So both this picture here is a picture of the same mineral. It's just that it's called hematite. Hema, like hemophiliac, like blood. And they have the same streak, which is a reddish brown streak. And the reason why it's like hematite is your blood has got a lot of iron in it. And that's why it has this rusty color. So essentially the one that's all red is kind of like oxidized. It's rusted over time. It's oxidized. So air and water have gotten to it and have made it, but they're actually the same mineral. So streak is a really good one. Yeah, that's why those are two different colors. So I think there's a question in there somewhere. Let's see here. Observe the streak below. It shows, yeah. So it says, why do you think the samples look different? And it says, hematite is a common iron oxide mineral, which means the mineral can rust. It's derived from the word meaning blood. Yeah. All right, cool. All right. Next is luster. And luster is the way that light reflects off of the surface of a mineral and to what degree it penetrates. So there's basically two different types of luster. There's metallic luster, and then there's non-metallic luster. But within metallic luster, there's like shiny and there's dull. So you know what a metallic luster looks like? It looks like, metal. But you know that some metal is really shiny, like even your aluminum foil has a shiny side and a not as shiny side. It's still the same foil. It's just that one side is going to reflect more light than the other. And so you can have dull metals and you can have shiny metals. So then there's what we call non-metallic. So it doesn't have a metallic luster. And so there's various ones. There's like an earthy one. So it looks like dirt. And then vitreous reminds me of glass because it's a glassy, it's got a brilliant waxy, looks like it's like oily or greasy. Pearly, yeah, it looks like a pearl. And then there's one that looks kind of, they call it resinous. It looks more plastic than glass. So it's still got that kind of like shiny, glittery appearance to it, but it's not like glass. It's more like plexiglass. So it's a little more cloudy, but still shiny and not creamy or pearly. And so I believe there's a question that says, answer the questions about the two specimens pictured. Oops, this time I actually pictured them. So sample A, what is its luster? So you're either going to say it's, you know, well, we can start with metallic or non-metallic. So is it metallic or non-metallic for A?
Maybe non-metallic.
Very good. It is non-metallic. All right. So going further, what kind of non-metallic luster are we talking about? That's right. Glassy, vitreous. Vitreous is a good example. Sure. And then what is its color? I would call it like white or clear. It looks like it's got some clear parts and some white parts. It actually looks like halite, which is salt. So, and then B, that has a metallic or non-metallic luster.
Well, B is definitely metallic.
Yes, very good. Woohoo! It's shiny. Like the wasn't it was that Moana with the crab who says I'm shiny? Got all that bling. Yeah. I think it was a crab. I could be wrong. Maybe it's not Moana. I feel like it was Moana because I remember going and seeing Moana and saying, that should have been Bruno Mars. That would have been a perfect character for Bruno Mars. But, you know, with his 24 karat magic. Anyways, sample B, I'd say it's like gold-ish color. So yeah. So it's metallic and gold colored. The next thing on our list is hardness. And I put a little hard hat there because I thought that was cute. So hardness deals with how resistant it is to being scratched or broken. You should know that diamonds are one of the hardest minerals or materials out there. But the hardness scale is based on how much one mineral can scratch another. So according to the scale, talc is the softest and diamonds are the hardest. And there are other things that geologists use to figure out, you know, how hard things are. So for example, your fingernail has a hardness of about 2.5 on the Mohs hardness scale. So it would scratch gypsum, but not scratch calcite. And so if it's harder than whatever the object is, it would scratch it, but it can't be scratched by it. So like a penny is at 3.5. So it would scratch calcite, but quartz would scratch a penny. Or actually anything harder than it would scratch it, but obviously a diamond would scratch all of these things. So if you took a diamond, you'd actually, you know, cut your fingernail pretty good with a diamond. I don't recommend it. If you have one just laying around. Another great, you know, graduation gift for Miss Pitts is, you know, just send me diamonds. I'll put them in my kit so that I have them, you know, for the Mohs hardness scale test. So, but basically that's how it works. If we were in class, then we used to have a test where we would, you know, do hardness stuff, but we damaged a lot of minerals, and so we stopped doing it, which is kind of sad. But I remember when I took my my geology and my geography class that we tested minerals to try and figure out what they were. But for the most part, it's mostly controlled by the strength of the bonds between materials. And so anyways, this is the Mohs hardness scale. So The next thing is cleavage and fracture. So how does it break? We call a cleavage plane something that is parallel on at least two sides. So if you can't put your fingers parallel to each other, then it's not considered cleavage. So some minerals have cleavage, some minerals don't. And then there's different types. So there's like one cleavage plane. That means it's flat on the top and the bottom, like a mica. There's two that break at 90 degrees, like halite. There's two that break at 90 degrees. They form like rhomboids or things like that. So calcite is a good example. So it's parallel on both of the sides, but they're not at 90 degrees. It's what we call a rhombus. No, rhombus is three directions of cleavage. 1, 2, 3. Yeah. So it has to do with, and then there's, some that have like a lot of cleavage planes. It just left my brain. They form little soccer balls. Garnets, sorry. They look like little soccer balls. Wish I had a picture of them. And then those are the ones that, we're going to talk about today. Oh, there's a question in there. Sorry. It says, if you had to describe this sample as a shape, what would the shape be of shape A? It's a box or cube. And then how many sides does it have? Well, it's like a die, so it has 6 sides. Woohoo! And then sample B, it's what we call and then there was a question C, how many planes or directions of cleavage does this have? So again, it's how many sides are parallel. So 1, 2, 3. So it's got 3. And then this is what we call a rhombus. So it's kind of like an off kilter. So they say the sides are parallel, but the angles do not meet at 90 degrees. So it's called a rhombus. Again, it has 6 sides, and again, it has 3 cleavage planes. So if we had it, we could pick it up and our fingers would be parallel to each other. So this was one we used to do in class. We did streak, color, luster, got rid of hardness pretty much. There were some that, we did do hardness with like talc and gypsum because they're readily available. Like wallboard is made of gypsum. Good wallboard, like drywall. It's got gypsum in it, so it's fairly readily available. But some of the other things we don't do anymore. We used to do acid tests. We stopped dropping acid. All right. There are other things. I like this. How does it break? I forgot to take that part out. I'm sorry. So one of them is like what's called diaphanity, which is transparency. Can you see through it? Does light transfer through it? Magnetism. So does it, attract metal to it? Specific gravity. One of the samples that he held up, he said, a little shiny metallic one. It was a little cube. He called it galena. Its identifying characteristic, besides the fact that it's cubed like that and shiny, is it's really heavy for its size. And that has to do with the specific gravity, which is how much it weighs versus how much it weighs related to water. So that used to be something that we could figure out. And then there are others. Smell was always a good one. Like sulfur has that like rotten egg smell, and halite, the one he put his tongue on, is salt. It tastes salty. But there are others that have different smells. For example, hematite smells like iron because it's made of iron, so it smells like nails. If you've ever smelled like fresh nails, not like your fingernails, but like at the hardware store. chalk. It's got like a real earthy feel to it in your hands. It feels, real soft, like chalk, like you'd write on a chalkboard or outside to draw your, hopscotch, things like that. Alum has got a sweet taste. So sometimes, and yes, again, we used to, you just have to take people's, after, one person has licked it. Do you really want to, I mean, come on, we're in a global pandemic. Should you be licking rocks? You just have to take people's word for it. So we stopped using those a long time ago. Taste, smell, we still used, but taste, we didn't want to encourage people to be licking rocks they weren't familiar with what they are, because there are some out there that, not the best thing to put in your mouth, just saying. All right, so now that we've identified minerals, and there are some mineral identification, there's a mineral identification activity that you should do. So you're going to pick one of those playlists and fill those out. So you're going to use the information that you have. And so I want to talk about how this basic mineral identification thing works. So let me show you one of those. So let's see here. You can pick any playlist. You just need to tell me which one it is. Let's all just do the second one. Hey, that sounds like fun. All right, so I'm going to click on playlist 2. All right, so this is that same, cool guy that, I wish I could be, but I'm not.
This is Kyle. He invented
Problem
one
with
wheel
these is there's
to destroy boredom.
All right, so this is our first mineral that we look at. So it's called 2.1. So we are going to go ahead and start by identifying it. So we start with, well, I would start with not necessarily color, because there's 2 different colors, but more that characteristic shape. We've already seen what this one is. I already told you what it was because we saw it in a sample before. This pyramidal kind of diamond shape to it. So you can see it has a pyramid on the top and another one on the bottom. So you look at that and you're like, okay, well, it looks like it can be purple or clearish or green. And it's got that crazy shape to it. So let's look for one that's got that crazy shape to it. So any guesses on what this one is? Does anybody remember when I talked about it before? It was the little green one. It's on looks like page 3. It has 8 sides, 4 on the top, 4 on the bottom. Is a vitreous luster, so that means it's glassy. That's right, it's fluorite. I wish that you would have shown more than just zooming around it in a circle. Let's look at the next one.
Wow, look at this.
Goodness, let's not.
94% of people believe company culture is important to.
All right, so then again, we look at this one. This one looks whitish or gray colored. It doesn't have any cleavage or fracture. Remember, they have to be like parallel sides. As far as its luster, it looks, I don't know, I'd say it's maybe like a waxy or cloudy. So that would be like maybe pearly, possibly. Definitely white. Guess might have one cleavage plane to it. Yeah. Say this one's probably talc. It might be gypsum. Wait. Back. Oh. Oh, look at that. It tells us down here. Well, that's cheaterish. Tells us what the streak is. Oh, cool. All right. Well, then this is easier than I thought. I don't have to walk you through this. All right. So here's all the information. It's white. It's got waxy or dull. Mohs hardness is 1. So this basic mineral identification table is put in order of softest to hardest. And so, you know, Mohs hardness 1, it's got to be talc. So it's the only one that has 1 as its hardness. So that's what you're going to do for the rest of playlist 2. So you can just say 2. We already did 2.1 and 2.2. You just have to rate the mineral, but that's what it's looking for. So yes, Philip, fluorite crystals is 2.1, and then this one's talc. So I didn't realize I should learn that there was stuff down here. You should have seen me last night. I was practicing. I was like, oh, okay. And I'm like, I hope I'm right, because this would be really embarrassing. So I wanted to go through it. That's why I said pick. That's why I went to sample 2, because it's the one that I really looked at. But I never saw this, which is kind of funny until now. All right. All right. So after we get done with identifying minerals, the next thing is talking about rocks. And there's 3 different types of rocks. There are igneous rocks, which are, there's 2 different types of igneous rocks. Well, actually, there's more than that, but there's 2 like big families of igneous rocks. So the first question, which is question number 13, it says, what types of rocks form from the cooling of magma? So here's magma. Here's cooling. It says intrusive igneous rock. So you just write igneous rock. What are the 4 processes that create sediments? They're up here: weathering, erosion, transportation, and deposition. Erosion and transportation is the same thing, but that's okay. What rock is formed when sediments are buried, compacted, and cemented? Burial, compaction, and cementation. Looks like sedimentary rock. What 3 arrows are pointing to the metamorphic rock box? So these are 3 rock types that can be transformed into a metamorphic rock through burial, heat, and pressure. Oh, well, gonna go with metamorphic can be there, igneous rock can be there, and looks like sedimentary rock can be there. So it's saying, how do you get metamorphic rocks? Metamorphic rock becoming more metamorphized, igneous rock becoming metamorphized, and sedimentary rock being metamorphized. All right, so first we'll talk about igneous rocks. They are the most abundant. It's where all rocks on our planet started. All rocks at one point were igneous rocks. Most igneous rocks are buried below the surface, but they're covered with sedimentary rock. So we don't really see how much igneous rock there really is on the earth, but here in Southern California, we get to see a lot of igneous rocks. So all of our mountains are made of igneous rock. So granite is an igneous rock. So all of the San Gabriel's and San Bernardino mountains are made of igneous rocks. The Sierras are made of igneous rocks. So we here in California have lots of igneous rocks to look at. So there are 2 basic types of igneous rocks: intrusive, those that crystallized and cooled inside the earth, and extrusive, those that crystallized and formed and cooled rather quickly on the surface of the earth. So those are the 2 basic types. And then within them, you can have anything from a light colored mineral, which is what we call felsic, which means it's mostly silicon dioxide, all the way up to what we call ultramafic, which are dark, really dark colored rocks. And this is a little chart that shows you as they go from light to dark in color. what type of rock they are, and then if they're extrusive, what kind of rock, igneous rock you have, and what it's called if it's intrusive versus extrusive. So this is, in my opinion, a really helpful picture. But you're going to do a similar thing. Actually, you don't. Oh no, not till later. So so this would be the chart table 2.2 that you would use to identify an igneous rock when you're doing your rock identification at the end of this particular activity. So I'll talk a little bit about that here in a second. The next type of rock is sedimentary rocks. And just like igneous rocks, there's two basic types, clastic and chemical. So clastic means they're made of clasts, and clast is just a fancy word for sand, silt, and clay. So they're made up of other, things. So smaller clasts typically are made of just one thing, like sandstone is made up of just sand, and siltstone is made of silt. I know sometimes they think of complicated names for things, but other times you have a chemical composition. If it's composed of just one big giant chemical, like calcium carbonate, which is CaCO3, or silicon dioxide. Silicon dioxide is what is a quartz mineral. And so most sand clasts are made of quartz because it's the most resistant to weathering. So we're at question 14. It says refer to table 12.1. What is the hardness of quartz? Do you think the hardness is one reason why quartz is more resistant to weathering than other common minerals? So let's see. Quartz has a hardness of what, 6 or 7? Let's see. Going back to my Mohs chart. I shouldn't have stapled my papers together. Dang it, where's my Mohs hardness scale? It was on another, oh, it's table 12.1. That's what I'm looking for. That's 12.8. That's a figure. Where's the table? Can't find the damn table. Sorry, darn table. Oh, here we go. It's on page 284. Quartz. I said it was a 7 or 8. There it is. It's a 7. So do I think that's one reason why there's a lot of it? Heck yeah. There's not a lot of stuff that's going to break it down. It's just going to be stuck around for a while. And then chemical, or whereas clastic sediment rocks are dominated by components that have been transported, sand, silt, and clays. Chemicals are dominated by things that have been transported as ions in solution, like shells and things like that. So question number 15 says, is the sedimentary rock example in 12.9 clastic or chemical? How do you know? Well, I said if it has like shells and stuff like that, or, it says that limestone is made up of entirely of fragments of marine organisms that manufacture calcite for their shells and other hard parts. Most chert includes at least some of the silica test shells of tiny marine organisms called diatoms. When these die, the shells sink to the floor. After a long time, these shells are buried, compacted, and cemented into a chemical sedimentary rock. So I'm gonna go with chemical because you can see the pictures of the little shells in there. So obviously it's got, those are some crazy old critters too. All right. So the next thing talks about different types of sedimentary rocks, everything from coquina to travertine. And so again, we'll talk about that here coming up. The next type of rocks are called metamorphic rocks. Foliated or non-foliated? That is the question. So foliated means there is banding to it. Non-foliated means that the stuff just kind of never really aligned with each other. It's all just kind of spread out throughout the rock. So a metamorphic rock is a sedimentary or an igneous or another metamorphic rock that's experienced tremendous amounts of heat and pressure. So it's kind of like been reburied. And then they typically have different textures than their parent rock, but they're made of the same stuff. So these are essentially the same rock, but they have different names simply because one's foliated, which means that it's got bands of stuff, and this is non-foliated. So that means that this one melted and then cooled. And during the melting process, the crystals were allowed to hang out together. And this one didn't melt all that much. It just kind of like turned into an ooze. It didn't get liquidy. This one probably was at some point recrystallized. So this one was heated a lot higher than this one here. All right, so all right, so number 16 says, oh, I don't have a picture of it. Oh, I have a picture of granite. Nice. Isn't that nice? Don't take it for granted. It's nice. So this is granite, which is an igneous rock. And when you heat and pressurize it, it turns into a very nice rock. Nice, get it? Nice. Okay. If you take limestone and you heat it and stuff like that, it turns into marble. Isn't that exciting? So, So then there's a table that helps us figure out how to identify metamorphic rocks. So the first thing you're going to determine, is it foliated or unfoliated? And then the marble's not foliated, just for the record. Gneiss is, but marble's not. It doesn't have like banding in it. It's just kind of like got colorful things in it. So let's go ahead and take a look at how to use this rock identification table. So let me switch over because I think that's the end of my slideshow. It is. Okay, so let's go to a new share, and let's go to advanced, and let's go to custom, and let's go to share, and hopefully this is going to pop up, and it's not because you never plugged it in. That's just great, Pits. How did you unplug your... I unplugged my projector. Talk amongst yourselves. There. Doo-doo-doop. 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 Okay, how about now? No? Still not showing. There it goes. All right. Can you see my hand? Oh, wait, I can't see your hand. I can see my hand, but I can't see your hands. All right. Now I see myself. That's not good. Let's try this one. All right, how about now? Are we good? Someone give me a thumbs up, or in the chat say yes, you can see what we're talking about. That's all I need to know right now, because I want to go through this basic rock identification and then tell you. Okay, cool. Thank you. All right, so how to use this these tables. So the first step is to determine the family of the unknown rock. So that means determine if it's igneous, metamorphic, or sedimentary. And then you'll use the table to determine the name of it. And then you'll go from there. You'll look at other properties along the horizontal row. So we'll do one together. So I'm looking for my rock, because I did bring one. Where is it? Is it in your pocket? No. Oh, here it is. All right. All right. So here's my rock. It's not a mineral, it's a rock. So first we have to determine if it's igneous, metamorphic, or sedimentary. So let's talk about how we might be able to figure that out. So let's start with sedimentary. The easiest way to determine if a rock is sedimentary is, does it have layers? Or does it feel like sand, silt, or clay? So I look at this and I don't see any real crystals or things like that. It does look sedimentary. Here's some banding in here. So it's either going to be sedimentary or it's going to be a metamorphic rock. It's definitely not igneous. It doesn't have a glassy texture to it. It doesn't look like it came out of a volcano. Let me make sure I didn't check that. That's a good question. Pitts, are you sure that it's on the list of rocks that we have? It's not. That's not nice, Pitts. Let me go get a rock that's actually on our list. Hold on. Talk amongst yourselves. Such a talkative bunch. Just talk my ear off. Couldn't hear you even. All right, I brought a whole bunch of different stuff. There we go. So let's see here. This is a mineral. This is that rhombohedron thing I was talking about. This is calcite, often confused with halite. So let me leave that one there. All right, let's start with this guy. All right, so well, actually, let's look at them all together. I don't think I have. Oh, this one's a. So this one here is an igneous rock. I know that because I just do. This is a metamorphic rock. This is a metamorphic rock. Oh, this is a good sandstone. Sorry, this is a good sedimentary rock. So it looks like it came out of the earth. It's it's got like a autofocus. It's got little pockets in it. See the little pockets? It looks like beach sand that's been squished together. So that's a good example. Here's another one. Most of the rocks I have are metamorphic because I spent a lot of time in the desert. And so they're either going to be igneous or metamorphic. So they were, igneous at one point, and now they've transferred into metamorphic rocks. So, so let's look at this guy. Let's say that, okay, so I'm just going to tell you it's a metamorphic rock. All right. So that only because I have the list right here. So we look at this and we determine if it's foliated or non-foliated. What does foliated mean? Does it have bands? I should have brought a foliated rock, but this one's non-foliated. And then we go with rock color. So we're at either quartzite, anthracite, or marble. So varies. White, pink, or gray, ain't that? Black with gold luster. What do you think? Yeah, that's right. This is anthracite. This is coal. If another 50 million years or maybe 50 years and tons of temperature and heat, this could turn into a diamond. So eventually, if I, had enough heat and pressure and time. This is what diamonds look like before they turn into diamonds. So yeah, this is the anthracite. So again, we look at it, we determine, sedimentary. Does it look like it's made out of, sand, silts, clays? Does it look like it might have been made out of sand, silt, and clay, and now it's turned into something else? Like this guy here. Or, oh, I don't have or is it really light for its size? And this is an igneous rock, believe it or not. It's not metamorphic. So let's do one for igneous. So let's look at the igneous list. Okay, so here's my igneous list, right? So I look at it, and then we have to determine if it's felsic, mafic, intermediate, right? So if you remember, felsic is a light colored rock and mafic is a dark colored rock. So it's kind of like not light. It's not like a white or a pink. It's kind of in between. So it's either going to be, an intermediate rock. Okay. And then we go with the color. So pink to peach. Aphanitic means you can't see the things that make it up. So if this were a igneous rock, this would be what we call porphyritic. You can make up the different things that make it up. You can see the different types of minerals that make it up. This one you can't tell. It looks like it's all made out of the same stuff. So that's what we call aphanitic. So yeah, this is rhyolite. So there are some examples in that list, and you're going to look at them and you're going to try and determine what they are based off of these tables. So let's do one together. Where in the world did I get these from? I picked them up on hikes. I used to do a lot of walking out in nature. So over the years, from the time I was a little kid, I've picked them up. This one here isn't on there. This is actually petrified wood. So from a friend gave this to me. They went to Arizona, brought this back, not from the petrified forest, but they picked up, they liked it because you can see, well, one, you can see that it used to be like a tree, looks like tree bark on the outside, which is kind of cool. And then you can see the various bands in here. But over the years, from teaching, students would like give me stuff. So I have like lots. I have an amethyst crystal that a student gave me. They're like, yeah, I just decided to get rid of it. I'm like, this thing is perfect. But it's at my other house in the desert. But yeah, just pick them up over time. I like to pick up crystal quartz because I don't know if we can see it in here, but next time you come across quartz, I wonder if I might be able to do it. Let's see if I can do it. If you strike two pieces of quartz against each other, you can actually see them light up. So let's see how dark I can make the room. It's gonna be tricky, but we'll see. Let's see if we can do it. Curious. All right. Let's see if I can make it spark. See that orange? Oh, there it is. Got a good one in there a second ago. Come on, baby. Oh, I can smell it for sure. See that orange pop out of there? Yeah, that's kind of, so I do that a lot with, I take high school kids all the time on hikes, and so I'll say, hey, look what I can do. I can start a fire. And if you have a barbecue, like a gas barbecue, when you push that little button, essentially it's doing the same thing that we're doing here with two quartz crystals. It's called piezo electricity. Piezo electricity. So it's the crystals, or because they have a positive and a negative side, actually sparking. So you can use that to start your barbecue. So, if I'm one of the cool people that, if I ever get lost in a forest, I might be able to survive for another 12 minutes longer than the next person. But who knows? So, ideally, you'll pick one of the lists. There are 3 lists to choose from. Playlist A, 1, 2, or 3. You're just going to tell me again, 1A, or sorry, 1.1, 1.2, or 2.1, or 2. And then what type of rock it is. So just give it your best educated guess, take a look at it. So if we look at this chart here, come on, baby. There we go. It says, if you can see separate mineral crystals in the rock that are randomly intergrown. So can you see crystals in the rock? And then if you can, then you go to step 2. Is the rock made up of just one kind of mineral? Oh, wait. Yes, go to step 3. If the rock has crystals of the same mineral, it's probably a metamorphic rock. This isn't, it's actually, so if they are banded or striped, go to step 5. If not, go to step 6. So this is what we call a rock dichotomous key. So it's like a if-then statement. So, if it's this, do this. If it's not, do that. A rock that is banded is probably a metamorphic rock. A rock with minerals in a mixed pattern is probably an igneous rock. But you'll see if you go to this one, can you see separate mineral crystals in the rock that are randomly intergrown? No. Go to step 7. Step 7 says, is the rock full of small air pockets? No, it's not. No, go to step 9. Does it look like a piece of dark broken glass? No, go to step 11. Is it made up of flat plates or sheets? No, go to step 13. Is it made of sand, mud, or gravel? Sure. 14. A rock that is made of sediment is a sedimentary rock. So you just go through the list and just do the best you can. And we'll review next week what y'all came up with. So we'll see how well we did. And if you want more practice on identifying, a particular type of rock, there's those, optional activities. And there's also some videos and stuff in here that show you what different, rocks look like. One tool that I used when I was growing up is I would just, type in, metamorphic rock identification with pictures, and you can see what a marble looks like, which is this kind of rock here, versus the schist versus an anthracite, which is this guy here, versus gneiss, which was in the picture. Slate looks like, you could write on it. So by light, things like that. So if you, had a picture of them, then it makes it relatively okie dokie. So so what I'd like for you to do, is like look at the samples, see if you can figure them out, try and figure out as many from one of the, let's just do playlist number 3, because I'm feeling lucky. So we'll do playlist number 3. And so take a look at that one, and then we'll come back next week and we'll see what we have. And we'll discuss how well you did. I'll give you the answers in live lab, and we'll chit chat about how you came up with them, or type out how you came up with them, or you could write it in your answers and then I would know already. But we'll see how you did. And then, if you want to, keep playing around, I do know what all of them are. So if you wanted to do a different list, then by all means do that. But I'll be reviewing list number 3 next week in class. Are there any questions? All right. Well, it's been my pleasure to hang out with you again. I look forward to hanging out with you again next week. Happy rest of your week. And you know me, if you have any questions, I can be found on email.